Hey everybody, this video is about chapter 2.4 complex numbers. Okay, and this should all be a review for you guys, so it's going to go pretty quick. So basically, when we say complex numbers, technically complex numbers are all numbers. So real numbers are complex numbers, imaginary numbers are complex numbers. Complex numbers have the form of a plus bi. Where a is basically what we call the real part. So that's the real part of it. And the bi is your imaginary part. All right, so just to remind you what I is represents a number which is the square root of -1. Okay, so remember, whenever you see lowercase I dealing with numbers, then we're talking about the square root of -1. Okay, so let's talk about I for a minute. What happens when you square I? So if you square I, that means you square this. And if you square the square root of -1, you get -1. So it's nice to memorize the fact that I squared is just -1. All right, now I cubed is, well, we can think of that as I squared times I, right? So this is one way to break it down. So I cubed is I squared times I. And we just said I squared is -1, so that would be -1 times I, or -I. All right, and then I to the fourth. Well, I to the fourth can be broken up as I squared times I squared, which is -1 times -1, right? So -1 times -1 is just 1. All right, then if we go to I to the fifth, we can break that down into I to the fourth times I, right? And we know that I to the fourth is 1, so that's just 1 times I. So it's just I. And there's a pattern here. I'll keep going for a little bit. I to the sixth is I to the fourth times I squared. Now we know I to the fourth, we just said, was 1, and I squared is -1. So this is 1 times -1, which is -1. I to the seventh, we could break that down into, well, we could break it down into I to the sixth times I. And we just said I to the sixth was -1. So -1 times I is -I. Right? And so forth. One more time. I to the eighth. I could break that up into I to the fourth times I to the fourth. And we know I to the fourth is 1. So 1 times 1 is 1. All right, so you see this pattern. We start off with I. So I to the 1 power is I. I to the second power is -1. I to the third power is -I. I to the fourth power is 1. I to the fifth power is I. I to the sixth power is -1. I to the seventh power is -I. I to the eighth power is 1. And you see this pattern: I, -1, -I, 1. I, -1, -I, 1. And it'll keep doing that. So if I wanted to know, well, what is I to the 100th power? Well, since 4 goes into that evenly, we could think of that as basically I to the fourth raised to the 25th power, right? And we know, because remember, with exponents, you just multiply these. And we know that's just 1. So it's the same thing as 1 to the 25th power, which is 1, right? If you wanted to know, well, what about the 101st power? Well, you could say, well, how many times does 4 go into 100, that's one way to do it. So for instance, I know 4 goes into 100 an even number of times, right? In other words, when I divide 4 into 100, my remainder is 0. So that tells me the outcome is going to be 1. If I divide 4 into this, and the reason I'm dividing by 4 is because that's the cycle. 1, 2, 3, 4, and then it starts over. 1, 2, 3, 4, and it starts over, right? So if I divide 4 into that, I get a remainder of 1. So I think I could just say it's the same as I to the 1, which is I. Just like on this one, if I wanted to, 4 goes into this evenly. The remainder is 0. So I could say this is I to the 0. And you should know that anything raised to the 0 power is 1, right? Here, since 4 goes into this almost evenly, but there's a remainder of 1, then the answer is I to the 1, which is I. If I do I to the 102, well, the remainder is going to be 2 when I divide 4 into that, so I to the second, and we know I to the second is -1, and so on. All right, so you probably have seen that in Algebra 2, hopefully. As far as numbers go, getting back to this, we know that all numbers can be written as complex numbers. So for instance, let me quarantine this off here. So for instance, the number 5 can be written as 5 plus 0i, right? Which is just 5. The number 3i could be written as 0 plus 3i. Notice I can write any number in this form right here, any number, which means all numbers are complex numbers. Now, so far, what we've been dealing with are real numbers. So we've really only been dealing with the first part of a complex number. In every number we're dealing with, the imaginary part has been 0. But now we're getting ready to do some more stuff with polynomials that requires us to deal with these imaginary numbers. All right, so let's talk about the types of numbers real quick, just a reminder. So we start off with the simplest numbers. If you remember, there's like, let me do it this way. So we have complex numbers. All numbers are complex numbers, all numbers. Now, you can break that up into 2 groups. You've got imaginary numbers. So over here, I'm going to have imaginary. Imaginary numbers are where the a part is 0. So like 3i or -i square root of 2, or on and on and on. Okay? So these are imaginary numbers. They always contain an I. And out here, you have other numbers that are, and over here, you've got real numbers. So that would be like, well, this is all we've learned about so far, the real numbers. So I'll do that in a minute. Now, outside of both of those categories are complex numbers like 5 plus 2i, or -3 plus I square root of 5. Right? There's all kinds of numbers. Now, so a complex number, usually when we say complex number, we're referring to a number that has a real part and an imaginary part. But technically, all numbers are complex numbers. All right, when we say real number, we're talking about a complex number that doesn't have an imaginary part. And that breaks down into 2 parts, right? So I can kind of cut this in half. Real numbers. You've got rational, and irrational. Right? So irrational numbers are those numbers like pi, square root of 2, e, most of the square root numbers. Remember, it's just a number that has a decimal part that doesn't end and doesn't repeat, right? Doesn't repeat. You can't write it as a ratio of two integers. A rational number you can write as a ratio of two integers. So for instance, 2/3 is a rational number, right? 2/3, because 2 and 3 are integers. And if you turn this into a decimal, you will get a repeating number. It doesn't end, right? It goes on forever, but it repeats, so it's rational. So if the decimal ends or repeats, it's rational. Now inside the rationals, you've got, other numbers. You've got the integers, right? So an integer is like, so within rational, you've got the integers. That shouldn't cross over there. So the integers, are counting numbers, like, and they can be negative. So dot, 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 -3, -2, -1, 0, 1, 2, blah, blah, blah. It goes on forever. Those are integers. Now, if you just separate the 0 and up, the positive ones, those are called whole numbers. And if you exclude the 0 from that group, those are called the counting number, the natural numbers, right? So you have the natural numbers is the simplest group. They start with a 1, and they just go on forever. Then you have the whole numbers, which is the next group up. It's exactly the same as the natural numbers, except it starts with 0. Then the next group up is the integers. And the integers basically are whole numbers and their opposites. So what's the opposite of 1? -1. What's the opposite of 2? -2. So dot, 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 -2, -1, 0, 1, 2, dot, dot, dot. Right, and then after that is your any kind of fraction you can make out of integers. Those are rational. Now, all of these technically are rational, right? These are all rational numbers because all of these numbers can be written as a fraction. The number 3 could be written as 3/1. So it's rational because you can write it as a fraction. This number 1 can be written as a fraction, 1/1. -2 can be written as a fraction, -2/1. So it's rational. Right? So any fraction of any two integers is rational. Okay, so that should give you, we've covered this before, that's just a recap. All right, so what we're going to concentrate on are these type of numbers here and these type of numbers here in this lesson. So I'm looking at page 148 here, and I'm going to pick out some numbers. So I'll just do some even numbers. So looking at problem 2 on page 148. The directions say find real numbers a and b such that the equation is true. So number 2 says a plus bi is equal to 13 plus 4i. All right, so find real numbers a and b. Well, obviously a is 13 and b is 4, right? So you just say a is 13 and b is 4, right? So 4 is your imaginary part and 13 is your real part. Even though they say find in the directions it says find real numbers a and b. Well, 13 is a real number and 4 is also a real number. But when you put an I next to that 4, this is imaginary. All right. And let's look at number 4. So number 4 says a plus 6 in parentheses plus 2bi equals 6 minus 5i. So the question is, what is a and b? Well, this is obviously your imaginary part, and this is your real part. So that means a plus 6 must equal the real part, 6, which means a has to be 0. And then your 2 plus bi, no, sorry, 2bi, 2bi is equal to this part, which is negative 5i, right? So that means 2b must be 5. So 2b is negative 5. Therefore, if I divide by 2, b is negative 5/2. All right, so that's just getting you used to the idea of, distinguishing between the real part and the imaginary part of complex numbers. In the next part, it says write the complex number in standard form. All right, so this I'm going to do number 6. And number 6 says 3 plus the square root of negative 16. Okay. So what I'm going to do is I'm going to break this up into 2 numbers. So I'm going to break this up into negative 1 and 16, right? Because if I multiply negative 1 to 16, I get negative 16. And then as we learned on the previous side of this paper, that's an I right there, right? So this becomes 3 plus I, and then square root of 16 is just 4, right? So that's 4, and that part's I. So typically what we do is we write this as 3 plus 4i. We put the I after the number. However, if you have a square root that doesn't go away, I always put the I in the front of the square root, right, which we'll see in a minute. All right, so this is your standard form of a complex number. Your real part goes first, your imaginary part goes second. Real part goes first, imaginary part goes second. Okay, let's look at another example, number 8. So number 8 is 1 plus the square root of negative 8. Okay, so 1 plus, now that negative can come out as the square root of negative 1. And 8 can simplify. Remember, you want to find the biggest factor of 8 that is a perfect square. In this case, that would be 4, and that's 2. All right, so what I did was the negative is here, negative 1, square root of negative 1. And then the 8 is the 4 and the 2. Now, this part, that's a 2, that's an I, so that's 2i, right? So I have 1 plus 2i, and then the square root of 2, there's nothing to be done with that, so I'll just leave it right here. So this would be how you would write that in standard form, as they call it. All right, let's do another one. Let's do 14. So this is negative 4i squared plus 2i. Okay, 2i, that's kind of done. That's your imaginary part. Remember, what is I squared? What did we say I squared was? So if you flip back in your notes, you see right here, I squared is negative 1. So we're just going to change that I squared to a negative 1. And negative 4 times negative 1 is just 4, so that's 4 plus 2i. So that is how you write this in standard form. All right, now let's talk about adding and subtracting complex numbers. Super easy. It's kind of like just when you add two polynomials together, you know how you combine like terms. Well, that's basically what you do here. So if I look at problems 17 through 26, I'm on page 148, remember. You might want to get your book out. Pause the video and get your book out if you're not doing that so you understand what I'm looking at. All right, so number 18, we have 13 minus 2i in parentheses plus, open parentheses, negative 5 plus 6i. All right, so to add these complex numbers, you simply add the real parts together. So 13 plus negative 5 would be what? That would be like 8, right? So that's going to be 8. And then you would also add the imaginary parts together. So negative 2 plus 6 is 4. And that's it. That's all there is to it. So you're combining the real parts. This is when you add or subtract I'm talking about, right? Now, if we're multiplying these, we'd have to do the FOIL method. We'd have to distribute. But since we're adding or subtracting, you just combine like terms, so to speak. So we're combining like parts, right? We have two parts here. We got real parts, we have imaginary parts. You combine the real parts together to get the first part, to get the real part of the simplification, and then you combine the imaginary parts to get the imaginary part of the number. All right, let's see, what's another one? So it was 18. Let's look at 20. 20 is a subtraction problem. So we have 3 plus 2i minus 6 plus 13i. All right, so same thing, but keep in mind we are subtracting here. So you do 3 take away 6. 3 take away 6 is negative 3. And then you would do 2 take away 13, which is what? Minus 11i. Because you're subtracting. So 3 take away 6 is negative 3. 2 take away 13 is negative 11. So it's pretty straightforward. You could also do this on your calculator. So let me just show you how your calculator does these. So I'm going to enter in parentheses 3 plus 2i. Now your I lives down here at your decimal number. See that little blue I right there? So you do second decimal to get the I. Close parentheses. Minus 6 plus 13 second decimal. And then, see, it gives me negative 3 minus 11i. All right, so you can always fall back on that. If you want to be super careful and you're allowed to use your calculator, you have that ability. Okay, so that was 20. And that's all there is to that. So I'm not going to go over any more of those. Let's look at multiplication. So looking at 28, you're multiplying the square root of negative 5 times the square root of negative 10. Now, since these are both under square roots, you can just go ahead and multiply, right? So square root of negative 5 times the square root of negative 10 is the square root of 50. And then you can simplify this. By simplify, I mean you're trying to reduce the number that's under the radical. So can I make it smaller than 50? And I can because 25 goes into 50. So I can break this up into the square root of 25 times the square root of 2. Why 25 and 2? Well, because the square root of 25 is a perfect square. It's just 5. So this becomes 5 square root of 2. And that would be your final answer there. Now, you could also do it this way. So that negative can come out as an I. So that would be I square root of 5 times that negative can come out as an I. So that would be I square root of 10. It's a little more complicated, but you can do it. Now, when you multiply these together, those i's get multiplied together, which is I squared. All right, and then, I get a different answer though, don't I? And then the square root of 5 times the square root of 10, that's the square root of 50. All right, so I think I lied to you. I think you can't just multiply these and get positive 50. I think these have to come out, so we'll check here in just a minute. So now I squared, we said was negative 1. And then the square root of 50, we simplified that. That's 5 square root of 2. So I end up with negative 5 square root of 2, which I believe is the correct answer. So I'm so glad I did it the other way. I believe I just corrected myself. So let's see what the calculator says on that. So I'm going to do the square root of negative 5 times the square root of negative 10. And it says non-real answer. Because my calculator's in real mode. I don't know if you can read that. It says real mode. So I need to go to my mode. So let me quit here. And I'll go to my mode buttons right here. And I'm going to change this to, you see the different modes here. You got real, and then here you got A plus BI. And then this other one is something we'll learn later. It's like polar coordinates. But this is your complex mode. So I'm going to turn that on. All right, now I'm going to quit here. And I'm going to go back up here and grab this and try it again. Notice I get a negative, right? I get negative 7.07 blah, blah, blah. Well, that 7.07 is the 5 square root of 2 part. So if I do 5 times the square root of 2, I should get that 7.07106, and I do. So, bad on me. This was incorrect, what I did here, right? When I multiplied this and got a positive, that is incorrect under the square root. You got to bring these negatives out as an I. And then when you multiply them, you get I squared, and that's going to result in a negative answer. So let's try another one like that. So that was 28. Let's look at 30. The square root of negative 75 squared. Well, we know that's just the square root of negative 75 times the square root of negative 75, right? And that's I square root of 75 times I square root of 75. Because those negatives come out as i's. And now notice the negative's gone, right? When I pull that negative out as a negative 1, it becomes an I. All right, now I times I is I squared. And the square root of 75 times the square root of 75 is just 75. Remember, I squared is just negative 1. So this is negative 1 times 75. So I end up with negative 75. All right, let's check that. So parentheses, square root, negative 75. Close it, square it. We should get negative 75. And we do. All right. So that's 30. All right, I'll do one more. Let's do 36. So this is 3 plus square root of negative 5 times 7 minus square root of negative 10. Okay, so the first thing I'm going to do is I'm going to pull out those negatives as I, so this will be 3 plus I square root of positive 5. And this will be 7 minus I square root of positive 10. All right, now because we're multiplying to, well, we can think of these as binomials. They're not polynomials, but it kind of the pattern's the same. So you'd multiply 3 times 7, which is 21, and then 3 times that, which is going to give you minus 3i squared root of 10. Notice I don't multiply the 3 to the 10 because the 10's under square root, the 3 is not. I just put it outside the square root of 10. But I can multiply the 3 to the I. Remember, I is just a square root, so it's kind of like I have the 3 outside of a square root here. Okay, so I did 3 times 7. I did 3 times that. Now I have to do I square root of 5 to 7. That's going to be plus 7i square root 5. And then I have to multiply this to this. That's going to be negative because positive and negative. I squared, right? And then both of these are under square root, so I could do square root of 50. Okay, so now we can combine these two. Well, no, I can't because that's square root of 10, that's square root of 5. So let's see what I can do. So I'll just bring the 21 down. Square root of 10, there's nothing you can't simplify that. You know, there's no perfect square that goes into 10, so you kind of just have to leave that. So that's just going to be minus 3i square root of 10. In the same way as square root of 5, you can't simplify that. So that's plus 7i square root of 5. I don't see anything I can do with that. Now this I can do something because I squared, remember, is negative 1. So minus negative 1. And then square root of 50, I know from a previous problem like we did up here, we can simplify that to 5 square root of 2, right? As I did up here. So maybe I should break it down again. So let me do that. Square root of 50 is the square root of 25 times square root of 2. All right, so all of this just comes down. I'm not going to rewrite it. It's just going to come down. And then this is a plus, right? That's a 5 square root of 2. All right, so it looks like what I've got here is 21 minus 3i square root 10 plus 7i square root 5 plus 5 square root 2. Now, if I were to write this in standard form, I guess this and this should go first, right? They should go together first because that's the real part. So the real part is 21 plus 5 square root of 2. And then I can do plus, the imaginary part is all this, right? And I'll just put this positive one first. So I'll do 7i square root 5 minus 3i square root 10. Now we can get an estimate on this out of the calculator. So let's see what the calculator says this is approximately. So I'm going to do the whole thing. So 21 plus 5 square root 2, close parentheses, plus, open parentheses, 7 second decimal point for the I, square root 5, move out of the square root to the right, minus 3 second decimal for the I, square root 10, move out of the square root, close the parentheses. I get this horrible number. So to estimate it, it's about 28.071 plus 6.166i. So that's an estimate. All right, now let's see if that's what I get if I put the original in there. So I should get that same very nasty looking number when I put the original. If I don't, then I made a mistake. So let's see. 3, I need to start with parentheses. I did. So 3 plus the square root of -5, move out of the square root, close parentheses, open parentheses, 7 minus the square root of -10, move out, close it, and I do. So all is right with the world. The original problem estimate is equal to my final answer estimate. So we're good. And I think that's all I'm going to do for today. So that takes us through multiplication, and then we also have to do like division, and that'll be in another video. But appreciate you guys hanging in there. Take good notes, work hard, and God bless you, and we'll see you soon. If I can shut this thing off. Sure how to get out of here. Here we go.